Hello, welcome to my channel CNCR Science and Math Concept. Here we are doing the question from class 12 physics topic dual nature of radiation and matter. The question here is a photon of wavelength 3310 angstrom falls on photocathode and an electron of energy 3 into 10 to the power minus 19 joule is ejected. If the wavelength of the incident photon is changed to 5000 angstrom, the energy of ejected electron is 9.72 into 10 to the power minus 20 joule. Calculate the value of Planck's constant and threshold wavelength of the photon. So first of all, here we are given wavelength 1 is equals to 3310 angstrom and energy of electron ejected with this wavelength is 3 into 10 to the power minus 19 joule. Then wavelength 2 is equals to 5000 angstrom and energy of these electrons ejected are 9.72 into 10 to the power minus 20 joule. We have to find out the value of Planck's constant and threshold wavelength. So now, how to calculate these values? We will see the formula that has to be used. Now here we know that the energy with which electron is ejected is given by energy provided, energy supplied minus work function. So here energy with which electron is moving is given by E1 is equals to hc by lambda 1 minus work function, and for second part it is E2 is equals to hc by lambda 2 minus work function. Since the metal is same, their work function will also be same. Now this is equation number 1 and this is equation number 2. I subtract equation 2 from 1. So we will get E2 minus E1 is equals to HC, I am taking common, 1 by lambda 2 minus 1 upon lambda 1. So now we put the values. E2 is 9.72 into 10 to the power minus 20 minus 3 into 10 to the power minus 19 is equals to H, value of C is 3 into 10 to the power 8 multiplied by 1 upon lambda 2. We'll check the value of lambda 2, 5000 angstrom. So 5000 into 10 to the power minus 10 minus 1 upon value of lambda 1, 3310 angstrom. 3310 into 10 to the power minus 10. So now we'll solve this. We consider this as 0.972 into 10 to the power minus 19 minus 3 into 10 to the power minus 19, which is equals to H into 3 into 10 to the power 8. 10 to the power minus 10 we take common. This is equals to 3310 minus 5000 upon 5000 into 3310. So this is minus. So minus 2.028 into 10 to the power minus 19 is equals to H into 3 into 10 to the power 18 multiplied by minus 1690 upon 5000 into 3310. So now we see for H, minus will get cancelled. Therefore, H is equals to 2.028 into 10 to the power minus 19 into 5000 into 3310 divide by 3 into 10 to the power 8 into 1690. On solving this, we get the value of H is equals to 6.62 into 10 to the power minus 34 joule second. So this is the value of Planck's constant. Now we have to do the second part. For second part, we'll check the question once again. In second part, we have to calculate the threshold wavelength. For threshold wavelength, we should know the work function. So here we are having energy with which electron will move is equals to hc by lambda minus work function. Therefore, we can say that work function is equals to hc by, if I take the first wavelength, so it will be the first energy. H is coming out 6.62 into 10 to the power minus 34. Speed of light is 3 into 10 to the power 8 divided by first wavelength was 3310 angstrom, that is minus 10, and energy of first wavelength was 3 into 10 to the power minus 19. So the work function on doing the calculation here, we get, if I take out this decimal and here it will be 100. So 3312 za, this is 10 za, this is 2 za. So this will give you 6, 3 2 za 6 into 10 to the power minus 19. On taking all the zeros, minus 3 into 10 to the power minus 19. So the work function comes out to be, work function is equals to 3 into 10 to the power minus 19 joule. And work function is equals to hc by lambda 0. Therefore, threshold wavelength will be equals to hc upon 3 into 10 to the power minus 19, which is 6.62 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 3 into 10 to the power minus 19. Now we solve this. 3 gets cancel. So what is left with us? The threshold wavelength will be equals to 6.62 into minus 19 will be go into the numerator will become plus. So it is coming out 10 to the power minus 7 meter, which can be written as 6620 angstrom. So the threshold wavelength comes out to be 6620 angstrom. That is all for this question. Keep watching my other videos for more challenging questions.